So, as we said in our previous class that we actually need to understand the basics of our clutches. So, as we had our introduction, now we are going to move forward into the advanced calculations that we need from basic principles, basics that we have, but we need to work with the calculations there. So in order for us to understand some of the calculations, there is a typical part that we need here on our presentation as we are going to be having our clutch. So we are going to be having the force, all right? In this case here, the force, which is actually the axial force or the applied force in this case here. So that is our force, our axial force. So considering working with an annulus, as we have an annulus where there is a consideration where you are actually working with concentric circles, the ones that have got the same center. You're going to notice that you'll be having the inner radius, which is this small r, and the outer radius. Those are the two things that you're going to be having. So in terms of the diameter, you'll be presenting the inner diameter and the outer diameter, depending with what you have. So that is the presentation that we are seeing here. This R for the what? Outer radius. The outer radius, and this one being our inner radius. And therefore, the pressure that is the ones that we're having. So these are friction surfaces, definitely, guys, that we are going to be working with. So I want us to consider, because it depends also with the number of the disc. As you can see there, with just a single disc or plate is just a presentation that we have. But like I was saying, I want us to consider, before we look into the calculations, when you are given this condition of concentric circles where we have got an annulus, a ring-shaped object with two concentric circles of two different what? Radii. If we are to calculate the area, we do understand the basics of our area. It's pi r squared. Like if you're just given a radius, pi r squared or pi d squared over 4. So if it is a consideration that we have these radius of outer and the inner, the area is supposed to be given by what? Pi. Then we have the difference of those radius being squared. So it is going to be r squared minus r squared, outer minus the inner one. So guys, meaning to say, if it was from the pi d squared, we could have just used the same consideration of pi d squared, the outer minus the inner over what? Remember, the whole formula is supposed to be over 4. So this is what we can talk about when it is area. So it is going to affect our calculations as we do understand them. All right, so guys, without wasting time, as we saw this diagram, the first part that we are going to need, we are going to separate our classes into 2 for these advanced calculations, because there's another part. I don't know how many classes are we going to have until we are done, because I saw like there are a lot of things, guys, but they are not a lot if we do revise these things. All right. Mechanotechnics N6, you need to know the exact concept of what you are dealing with. If you just know the concept, do as many question papers as you can. So we shall try to do as many reviews or introductions, I don't know, up to the end. We shall see. So the first part, guys, that we're going to need is the axial force. So that is referred as FA. So the axial force is simply taken from the pressure. Remember, if you're given pressure, we know that pressure is force over area. So you can make force the subject. So therefore, force is pressure times what? Pressure times area, simply cross multiply. So that is why we are going to have it as force is equal to pressure times what? Pressure times area. So that is the consideration that we are having there. So this is our pressure, guys. All right. So that's our pressure in what? In pascals. And there we are going to be talking about our area in square meters. So remember, force is measured in what? In newtons. So whatever that we are going to have is going to be in newtons. So you see where it is coming from. Those are the basics that we know. So from there, we manipulate to make our force the subject. So the area now that we are having, remember the part that we are talking about here. We are dealing with an annulus. So at the end, our area is going to be what? Can be taken from this, which is our radius. We're using radius or using what? The diameters. So in place of that A here, we are going to substitute those two formulas depending with the one that we are going to have. So definitely, so here we can say our force, which is the axial force, is equal to pressure times area. So area now, we are back to these two. So having this of the radius, we are going to have what? Pi into what? R squared minus R squared. Are we seeing where it is taken from? So that is from the annular surface area as we have it. Or it can be in terms of diameters. Let's say you want to use the diameters because that area, guys, we saw that area can be given in terms of what? In terms of the diameters. So you can also have it in terms of the diameter. So it means it will be pi into what? In terms of the diameters, we saw our formula is d squared minus d squared over what? Over 4. So this is our area. So what is important is we are dealing with area. So that can give us the same axial force. So it depends with the information you want to deal with the radius or what. So one pair of, if we are to consider that, if we consider like one pair is the flywheel and the clutch plate. And the second one, we're going to consider the pressure plate and the clutch plate. So, but as for the basics, guys, I want you to know this formula here. That is what you need here. And we are going to use this formula in as much as we can. So what is, so like I said, A is the area, which is the area of contact. Then P, there is the pressure. So here we are done. All right, let's move on to another part of our calculation also that is important, which is the number of contact pairs. The number of contact pairs. Number of contact pairs, which are the contact surfaces. So these are the contact surfaces. All right. So we can be asked to calculate the number of contact surfaces required. Okay, which is our N. So our N is given by the formula from torque. Remember, let me have the formula for torque. It's not for now, but we're supposed to use it to take it from there. The torque is given as, okay, the coefficient of friction times applied force times the mean radius times the number of these contact surfaces, which are the contact pairs, which is this one. So as we can see, by making this the subject, by dividing by this here, we are simply going to have it as the subject. So it was going to give us the torque over what? The coefficient of friction times the applied, which is the axial force times what? The mean radius, Rm there being the arithmetic mean radius. So this will give us the number of contact surfaces. So as you can see, I said T is what? Is the torque. Okay. The coefficient of friction. So guys, for those who think like we waste time writing a lot of things that could have in maybe Sean. I don't know, guys. The presentation is different. I present differently. My presentation is different. So I don't know. I do not know, guys, but my presentation is totally different. And that can help you if you are new to know that our presentations, they are different. I want all of us to understand, because some of us, we know these basics, all right? Some of you, you do not know these basics. So if you know the basics, then wait for the question papers when we shall be doing the question papers. But for those who want to know the basics, then make sure that you watch the videos up to the end, and also join membership so that you do not miss any of the other examples. Because I was actually doing examples to public, like for public videos. But most of you, the comments now, you'll be saying, what's the purpose of having a repetition of an example which is in a textbook? Guys, I do not know. An example, if you want me to do an example, what type of an example am I supposed to use? An exam, like, I don't know. So that's why I keep those examples now for membership. They are only for membership now, so that we do not have stress, guys. So for those ones who'll be wondering why we are not getting videos for examples, we are just getting introductions, it is because of that. Some have been complaining. It is just like maybe a waste of time. I have this example in the textbook and we're repeating that example. The purpose of that, it was, we need to know what is happening, because others, they need to know that. So for those that need to know that, guys, in detail, membership is there for you. You join, then we see. So that, okay, guys, let us continue. I just hope we're going to talk about that as just a separate video, not as a class, that can help. So I was saying, guys, this is what we have. The T is the torque there, which is measured in Newton meter. The coefficient of friction, the axial force, we talked about this before, the mean radius. So that can give us the number of contact pairs at the end. Another part that we are going to need is to calculate the angular velocity. The angular velocity. So as we can see, guys, here we are still part of our engineering science. That is our angular velocity. Remember, from our engineering science, guys, we are saying that angular velocity, which is omega, can be calculated when we are given the speed in revs per minute. From what? From the formula 2 pi n over 60, which can give us the omega in rad per. Guys, be very careful. The angular velocity, it's rad per second. Rad per second. The rev per minute, rev per second is the speed. So if we wanted to use that, it's only that there is this n here, which is representing the number of contact pairs. So guys, you'll be thinking like it's one and the same thing, but let me just specify here that if we are given the omega, if we are given the speed in revs per second, our omega, which is the angular velocity, will be given by the formula 2 pi n in rad per second from our engineering science. Guys, I talked about this. So this being in revs per second, this one. Remember, 60 there is to remove per minute. As you see, revs per minute. Why dividing by 60 this one? It is to remove that so that our answer have per second. That is the purpose of this 60. So it means it is used when this speed is in what? Revs per minute. This one is used when you have the what? The revs per second. We have to calculate, guys, when you are given revs per second, you must calculate the omega. I'm saying this so that will be together, because there's another error that happens. Even some of the textbooks, even under exam. Remember, guys, these are people also that are writing textbooks and these exams. They can make errors. They give you a formula where the revs per second is this one. They take it as omega. No, 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 guys. You must calculate omega from there, just like if you are given n in revs per minute. So I want us to be together there. All right. So anyways, guys, let us see where this omega, which is our angular velocity, as we can see, angular velocity, guys, it is just like speed. So as we know, we have been talking about this consideration, guys, when we refer to the linear. V is equal to U plus what? Plus AT. What were you talking about there, guys? Linear velocity. Now we talk of angular velocity. So it means the final omega 2 can be given from the initial, which is given as omega 1 plus this A. When it is under angular, it is angular acceleration times the time. So what I want you to understand, because we are dealing with the angular values, angular motion, it follows that. I want you to be careful there. It follows that the omega 1, this one, is the one that you're supposed to calculate from the given speeds. All right, let me make it here. Not. Omega 1 is to be calculated, from the given speeds. From the given speeds. From the given speeds, depending with what you'll be working with. Remember, for those speeds, we shall be considering working with an engine shaft, working with the machine shaft. So the engine shaft has its speed, the machine shaft has its speed. So that will help you to calculate omega 1. So take note about omega 1. So omega 2 cannot be calculated direct, because remember on our introduction, guys, we talked about the condition when our shafts, when we talk about having the same speed at the end. We said due to this, the slippage will occur until the two shafts rotate at the same speed. Remember, I talked about that when the two shafts end up rotating at the same speed. So that's omega 2 now, this one. This is our omega 2, this one. So the omega 2, okay, omega 1, guys, is simply initial. Okay, so this one is initial. Remember, that's our starting point, initial velocity, all right? Angular velocity. Then the omega 2 now. The omega 2, which is our final angular velocity, this one, which is our final angular velocity. Final angular velocity is the one when the two shafts rotate at the same speed. That's the final speed when the two shafts are at that same speed. All right? So that's the same speed for the what? This one. That's the same speed taken for the two shafts. For the two shafts that you'll be working with. So that is the major case. At the final speed, they'll be at the same speed. I mean, at the final consideration when this slippage occurs. And the slippage occurs until they are at the same speed. So it means that will be our final. Until, guys, it means we started with a certain speed. We started with what? This initial. Until we get omega 2. Until we get that one, omega 2. So the omega 2 is the final. So that one is supposed to be equal at the end. So in actual sense, we are simply saying, all right, let me write it here. Omega 2 is equal to omega 2. So does this make sense if I say omega 2 is equal to omega 2? No. It makes sense if we specify which omega 2 are we talking about for the two shafts that we're going to be having. So we're going to have the engine shaft. So the omega 2, which is the final angular velocity. for the engine shaft must be equal to the final angular velocity of what? Of the machine shaft. Please be very, very careful there. So with this consideration, in most cases, you are going to see with this information, you will need it to calculate the total time of what? Of sleep. So I'm going to explain that one when working with examples to calculate what? To calculate total time of sleep. Total time of what? Of sleep. So it's only that I removed those notes that we had in our previous class, but I explained, guys, from our previous class when we talk about the functions on that, on those notes on function, there's a statement which was, I think the third statement, which I was saying, due to this part which was taking place between the driven shaft and this and that, slippage will occur. We said slippage will occur. Slippage will occur until the two shafts, rotate at the same speed. If we understand this statement, guys, this statement is very important. Until the two shafts rotate at the same speed. At the same speed. It is going to help us a lot. So until they rotate, that's the final part. So that final speed is our omega 2. So meaning to say those two will be equal because we are saying same speed. Yeah, that's the same speed, the final same speed that we are talking about at the end. So to calculate now the total time of sleep, guys, the sleep is the one that is for sleep. We are saying slippage here, slippage here, here. The slippage, okay, until they have the same speed. So when they have same speed, that's when we can solve for t because it's an equation. Remember, omega t is in term omega 2, this one, sorry, is in terms of what? Is in terms of t. So you simply have to solve for what? Solve for t when omega 2 is equal to omega 2. When we say omega 2, you're talking about these two, the one that I specified, guys, of the engine and that one of what? Of the machine. When those two are equal, we can solve for what? For t from there. So guys, I want you to use this part to answer any question that has this consideration. So that is it, guys, from this part. What else can we have before we finish up? Other formulas that maybe we can just need because these are the ones that we're going to have or that we're going to use for the first class of our calculations because we are going to need to do examples using this information alone. So guys, like I said, here we do not rush. We're not going to rush. We're going to take our time until we finish. We were rushing before, but we saw that there's no need for that, guys. Let us see if we can understand, all of us. That is the major part, all of us. So other formulas that we can simply need. We talked about the mean radius here. Yes. We talked of the mean radius. Somewhere here, we talked of the mean radius. So that mean radius can be calculated from these two radii, the outer and the inner. They can give us the mean radius. So Rm, which is the mean radius, can be calculated. Guys, mean is average. Average from our mathematics, average, you add the two. If they are two, you add them, then divide by what? By 2, average. All right. So that is mean, average. So that's our mean radius, which is supposed to be in what? In meters. So that is it, guys, on our mean radius. So that is one that we're talking about. Another thing, we talked of the torque. The torque, this one, the torque. The torque also, remember from our engineering science, because these are, guys, we are saying advanced decalculation. From where? from basic principles. Let's go back to where the torque was found. Remember, power. Okay, another formulas that you can consider is of the power. Remember, power is, we said this is 2 pi n t over what? Over 60. If your n is in revs per what? Per minute. Meaning to say, if it was in revs per second, our power is going to be given as 2 pi n t like this, if this one is in revs per second. So t is the torque, this one, which is also part of our calculations here. So maybe we're not given that, they give us power. Where are we going to have that torque from? Guys, we can make it the subject by cross multiplying. It's going to be 60p is equal to 2 pi nt, because this is the same as over 1. So you cross multiply. So meaning to say, to make t, we're going to divide by what? By 2 pi nt. So meaning to say, from this consideration, therefore it follows that torque is equal to what? 60p, which is the power, over what? 2 pi n over 2 pi n, like this. So this will give us the torque from this. So from power, we can calculate our torque, which is measured in Newton meter. So meaning to say, if it was from this formula, guys, if it was from this one, which is in revs per second, our torque was going to be power over 2 pi n in what? In revs per second, as it is. So that is it. Sometimes there is a need for you to play around with formulas, also making or change of subject, guys, because they can give you here this formula, guys. Look at this formula that we have. They can give you this formula. They want you to play around with it. Make the subject, change of subject. You can find whatever that you want. Where the radius is, they can ask you to calculate a diameter. Know that radius and diameter, they have what? A relationship. The diameter is equivalent to 2 times what? 2 times the radius. So if it is the outer one, is 2 times the outer radius. If it is the smaller one, is 2 times the inner. Same concept. If we are given that radius, I mean the diameter, we can calculate the radius, because diameter over 2 is going to give us radius. So it depends with what you're given. Learn to manipulate formulas. Engineering and mathematics, I said, guys, they go hand in hand. Your mathematical concept, let it be used. So in our next class, like I said, we are going to be looking into examples now on how to apply these formulas. Then we continue with our formulas. We are still there on advanced calculations, guys. We are still there. We are not yet done. So for now, we are going to end here, but we are going to have questions following this so that it can help us. So let's also communicate on in the comment section about that part that I was discussing, the issue of what questions, examples to be public, or we maintain the way that we are still having it to be on what? On membership. So that is it, guys. Till we meet again.